The NESI board has two groups of LEDs, a red set and a blue set, with the board oriented like this. The blue LEDs can be found on the top here, 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 and here, and the red set can be found on the bottom here, 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 and here. While there are 8 LEDs, all of the red are wired together and all of the blue are wired together. This means that groups of red and blue can be controlled independently from one another, but individual LEDs cannot. Because LEDs will only work if installed the correct direction, find the lead nearest to the flat spot on the LED. This lead is negative. Orient the LED so that the negative lead is closest to the flat line marked on the NESI board. Make sure that you're installing the correct LED to the correct slot on the NESI board. So this is a blue LED. Make sure it corresponds to the B mark on the NESI board. So once the LED is into that slot on the NESI board, go ahead and flip it over and solder the LED onto the board and trim off any excess lead. Do the same thing for the second LED, ensuring that the flat slot lines up with the white mark on the NESI board. And I'll go ahead and slide it down. Now that we're done installing the red and the blue LED, we can go ahead and begin programming them.
So in order to demonstrate the usage of the LEDs on the NESI board, we're going to go ahead and make a simple program which will turn the red LED on, then flash between the two, so red then red then blue, and so forth. So we're going to go ahead and open up MPLAB X and a new project. If you don't know how to make the new project in the main.c file, another video should explain that here. So go ahead and navigate to your project and where your main.c file is, and we're going to go ahead and open that up. So in here, in this main.c file, the LED library contains all of the functions necessary in order to use the LEDs. So we're going to go ahead and include that library. Include, and in quotes, we're going to go ahead and put led.h. This will include the LED library, which has all of the functions for controlling the LED in it. This isn't really necessary, and if I was actually programming something else, I probably wouldn't put it there, because this led.h library is already included since I included NESI.h. So this NESI.h, if you actually open it up, you'll notice that it already includes the led.h, so it's not really necessary. But for the sake of example, we're going to go and put it there. Also, I'm not really sure about the LED's initialization functions, but we're going to go ahead and include it because it's good practice, and if we don't include it, it might not work. So we're going to go ahead and do, just to be on the safe side, we're going to go ahead and select the LED, the red or the blue. So you can do that by typing LEDR or LEDB. We're going to go ahead and do LEDR first, and we're going to do the init function, which initializes the LED. These two parentheses, if you're new to programming, those contain parameters, because the initialization function doesn't have any parameters for the LED. We can go ahead and not put anything inside of those. So we're going to do the same for the blue LED, ledb.init. And that should initialize our LED. Now in the while loop here, this is going to cycle over and over again. We're going to go ahead and put in the code that actually turns on and off the LED. So we're going to go ahead and put in some pseudocode here. We're going to turn the LED on, or the red LED on. Then we're going to go ahead and wait for 1 second. Then we're going to go ahead and turn the red LED on, off, and we're going to turn the blue LED on. And next we're going to wait for another second. And then we're going to turn the blue LED off. Now, the reason why we don't have to then turn the red LED back on is because this is going to cycle back to the first function here, which is going to turn the red LED on, and the time between those two functions is very, very small, so you won't notice any real like time at all. So that is the pseudocode that we're gonna be performing, but let's go ahead and turn that into real code here. So for turning the red LED on, there's a function that's used quite often in programming the LEDs on the NESI board, and that is the duty cycle function. So we're going to select red LED by going LED R, and we're going to do duty cycle. And inside this duty cycle function, you can see it does take a parameter. It's an unsigned short, which is like an integer, so we're going to go ahead and use 100. This 100 here, in order to actually understand this parameter, you really kind of have to understand how this thing works. So this runs on a thing called pulse width modulation, or PWM, and that basically turns the LED on and off like a lot of times per second, very, very quickly. So you'll actually see it getting dimmer as opposed to blinking. So this LED R.dutyCycle 100 is going to make it on for 100% of the time. So when you select that, there's no time that the LED is off. If we were to enter 50 here, the LED would be blinking on and off, and it'd be off for as long as it would be on, so it'd be on for 50% of the time. If we wanted it even dimmer, we could go as low as like 1, and then it would take one period of time on, and then another 99 periods of time off. But for now, we're going to use 100 because we want it on full brightness. So now we're going to wait for 1 second. We're going to go ahead and use a standard function. Functions, I would recommend not using it too often, but it's underscore delay underscore ms and then 1000. This delays it for a certain number of milliseconds. So delay ms halts the entire program for 1000 milliseconds. It counts 1000 milliseconds, and it'll go and resume. But there's another function called microseconds. There's another function called us, which is for microseconds, but we're going to be using milliseconds here, so we'll just do ms. I wouldn't recommend using this function too often, because whenever you do call this function, the entire program is halted for that amount of time, so nothing else can happen. So if you wanted it to detect, or if you pushed the button during that delay period, the NESI board wouldn't even pick up that button press because it's busy counting these milliseconds out. There are better ways to do delay, or to do delays in the program, but I'm not going to get into those right now. So next we're going to go ahead and turn the red LED off and the blue LED on. So you can go and use the duty cycle function for that. So LED R.duty cycle, and then 0 because we want it on for 0% of the time. And then we're going to do LED B.duty cycle 100. We're going to wait for another second, so we're going to use that delay ms function. And we're going to go ahead and turn the blue LED off. By setting the duty cycle to 0, so it's going to be on for 0% of the time. So this function will run, and it'll run again. So as soon as it turns the blue off, it'll go back to the start and turn the red off. It's also perfectly valid to take this particular function and add it to the end, because it'll do the exact same thing except it'll start by waiting 1,000 and then it'll do its cycle. Oh, I'm sorry. But I'm just going to keep it like that for now. So now we're going to go ahead and make the program and hope it builds. So it looks like our building of the program was successful. So now that's done, we can go and program the NESI board.
So in order to program the NESI board, we're going to go ahead and plug the standard USB Type B plug into the NESI board here, and we're going to go ahead and attach the programmer up to the programming header here. Make sure it's oriented the correct direction. We're going to go over to our MP-Lab X, and we're going to go ahead and hit program. And we're going to, and we'll wait for a second for programming to complete. And a quick tip of advice here: make sure that the NESI board is actually turned on before you try to do that. Otherwise, there's a good chance it won't work. So now that the board is programmed, you can go and disconnect the Picket 3, and you'll notice that the NESI board is doing what we told it to do, which is blink blue, then red, and blue, then red. So our program worked successfully.